Hello there and welcome. It's another episode of In It 6 with your friendly CCI Advisory Council people around the table today. We've got a new member with us. John, would you like to introduce yourself?
Yeah, so John Amer. I work for a global managed security provider. I've been in networking since I'm in 1997. Been a CCIE since 99. I guess I've been through a few transitions from, SNA, DLSW, IPX. Remember that
Yes.
Novell protocol,
Oh, yes.
etc. And I'm looking forward to the next transition. Programmable networks, APIs, and how that'll, I guess, take me into the rest of my career. So that's me. I'm saying nothing more else.
Well, that's perfect, mate, because that's what we're here to talk about, right?
Thanks for joining us, John.
Yeah, thanks for coming, mate. And we have another guest from Cisco with us. Matt, would you like to introduce yourself?
Wait a minute, hold on. Not just another guest.
Of course. Sorry, I missed the big sell.
He's the wizard of DevNet. This guy can teach DevNet to a rock. So, without further ado,
I love that.
And there's 5 rocks in the room.
Yeah, that's true enough.
Rose, in the previous episode, did a pretty good job teaching DevNet to rocks. So I have some big shoes to fill today. So thanks for the introduction. My name is Matt DeNapoli. I work for the DevNet program out of Cisco. I'm what's called a developer advocate. And I do teach a lot of different things around network programmability. My history with Cisco is long and distinguished, if I may say so. I've been with Cisco since 2007. I did start out in wireless, and in some way, shape, or form, I've always worked in the wireless space. I started with an old program called CCX, Cisco Compatible Extensions, and what that was a program where we would test out wireless NICs, and I'm talking about when we had the actual cards that you slid into your laptops, and we would test those with Windows XP and Windows 8 drivers, interestingly enough, and we would provide an SDK for our OEMs, the Atheroses and the Intels of the world, to build out a infrastructure or a driver that would allow them to work with Cisco wireless infrastructure, which at the time was useful. And the program kind of oddly still exists a little bit. We don't do the testing or any of that anymore, but there are some little cobwebs in the back where that CCX program is still has its little dust bunnies. But that being said, things moved more interestingly forward. I started working on what was used to be called the Location Services Engine, and then the Mobility Services Engine into CMX. All of those were fancy acronyms and names for being able to track devices in a wireless space. And which you would think, and this is the thing that I always found interesting. We have GPS and we track devices through GPS, and that all sounds all fine and good. And you think, if you can do it with GPS, it should be really easy to do it with access points that are much closer to each other. But the thing with GPS is that because it's so high up in the sky, line of sight is actually a lot easier to maintain. So with wireless access points, we have to do some special math, as I like to call it, to figure out where these devices are located in. Over the years, those locations have gotten better and better, and we've been able to up to maybe 2 years ago advertise meter location or within a circle of a meter location accuracy for devices, and so that got pretty exciting because I remember our first DevNet zone. I had people coming up to me asking me about the location services for CMX, and they were like, well, why is the error so big? Why can it be like a 20 meter error or a 20-foot error, depending on how it's configured? And I said, well, I mean, you're dealing with walls and you're dealing with people and you're dealing with other radio interference. And these access points are basically guessing based on that material. And they're like, well, that's dumb. And then they would walk away and get all upset. So I got really excited when we got to the point where we could offer what we called hyperlocation at that point in time. So there is ultimately going to be an evolution in wireless offerings, and hopefully for those location services, it improves even more with those wireless updates. And so I have a number of different things to go through, if that's all right with you guys, and jump in, ask questions, and we'll move forward with that. So the first thing I'm going to kind of kick off with is, since we are focusing on wireless, I'm going to start with my wireless dev center. I should say our wireless dev center at DevNet. And the first thing you might notice is that there is a kickoff here that indicates the movement to what's called Wi-Fi 6 or 802.11ax or 802.11ax. This is actually a pretty large jump in the improvement of wireless connectivity. And actually, the way that it's being touted is that this is wired on wireless. And so that is very exciting for people who worked in the Wi-Fi space and have had to deal with consistent packet loss and being able to build out applications and data streams that handle those things like jitter and data loss and stuff like that. And so as these access points get pushed out into the public space, whether it be your homes, offices, schools, whatever, you're going to see a marked improvement in how that works, because the physics of how the access points work, the software that's managing the access points themselves, or I should say firmware, not the software, is improved, and there's improved algorithms that are being applied as far as the data streams are concerned. So we actually have, I believe there's a video on this dev center that shows test driving this Wi-Fi infrastructure. I'm not going to play it right now, but it's a really interesting tracking of packet loss for a video stream. And what it notes is that there's I think it was something on par with either 100 times improvement or 1,000 times improvement over the number of packets that were lost. And if I remember correctly, the one that was on the current version of Wi-Fi or Wi-Fi 5, which is the latest one, we lost something like 2,000 packets over the course of the stream, whereas in the Wi-Fi 6 data stream, they only lost 2. So we're seeing a marked improvement in Wi-Fi 6. Now, the kind of head scratcher for all of this is, what does this mean for our application developers? And since I'm from DevNet, I kind of have to turn all of the subject matter towards either application developers for network programmability or using APIs to that point. And so we kind of did some brainstorming, and we struggled with it a little bit, because from an infrastructure standpoint, it doesn't have a lot of changes. There's no new APIs that are coming around for that. There might be some new features and functions we could take advantage of, but there's no big jump in what we can do directly to the devices. But what we can do is take advantage of these improved data streams and build out AR/VR experiences that are more mobilely inclined. You're starting to see companies like Oculus and Samsung come out with these headsets that don't need to be, or actually they've been out for a year or two, that don't have to be hooked up to a PC to work. And we'll see improvements in those experiences going forward with AR/VR. The big jump, and the one that kind of is Cisco angled, is more IoT applications. We can start to deploy through 5G and Wi-Fi 6 these networks that take on these, what we're going to say, and I can't remember off the top of my head the exact number, but I think that you always see these reports from Gartner and Evans Data that say things like, in 2030, there will be 21 trillion devices on the internet. And a lot of that is going to be tied to these IoT applications. And historically, those things could have been limited by how quickly the data could be sent for a sensor, or a self-driving car is a big one that comes up as far as the need for speed for sensor data. City management, all of those things that fall into that IoT application space can be benefit by these improved reliability of the data connection and the improved speed of the data streams. This also comes in high density deployments, and we have a stadium here that shows that. And I'm sure if you've ever attended a game or or even a conference, you'll notice that sometimes the Wi-Fi can get a little dicey, and I will even claim that Cisco sometimes has that issue at Cisco Lives. But I think, and hopefully I'll see, that this will become a thing of the past as we get into situations where there's 25, 50, 100,000 people in a concentrated space in these deployments because of the improved physics of the way that these access points work and the improved firmware that manages the data streams. So that's the kind of overarching, hey, why Wi-Fi 6 is great. Doesn't necessarily tie to Cisco, but the reason that I wanted to mention it first is that there is a little bit of confusion, I think, in the space of how Cisco offers Wi-Fi and or what Wi-Fi platforms are available from Cisco. So historically, there was Cisco Unified Wireless Networking, and that had all of our AeroNet access points that we see all over the place, right? And then a few years ago, Cisco bought a company called Meraki, and some of the confusion comes in there because Meraki is not just Wi-Fi. I actually got assigned to Meraki as the developer advocate because I was the Wi-Fi or the wireless developer advocate, and people just thought, oh, well, it just goes to follow that Meraki is wireless, and Matt should cover that. Well, interestingly enough, the more I dove into Meraki, the more I realized that Wi-Fi and access points are just a tip of the iceberg for Meraki, and but it is another offering that Cisco provides. Now, interestingly enough, they can exist within the same infrastructure, but they are managed in separate ways, and so they are two separate product lines. Cisco Unified Wireless Networking manages now those AeroNet access points are moving to a new terminology, Catalyst, and that falls in line with the switches, the switch naming convention that Cisco uses. But then Meraki has their own product lines, and so I just wanted to give everyone kind of a quick look of what we're looking at here, all of the information around the products.
Do you see much of that? I don't know if this is the right term, but hybrid approach, Meraki and Unified Wireless. Do you see those together, or you were just mentioning it as far as a possibility?
So what I mainly see are instances where the back room will have Cisco switches and routers, and then Meraki access points will be deployed. So, for example, I have this one organization sitting up here, and this is a office, co-working office space that I know the owners of, and they were running Meraki, but in their back room they have I think 7 or 8 Catalyst switches running that. So Meraki has switches and what they call MX appliances, which kind of fit in the whole like router security infrastructure space, right. And then they have the access points on the edge. And it works with their infrastructure, but it also works without having to have that core infrastructure in place or that backbone infrastructure in place as well, which is why I mentioned it. But what I want everyone to kind of understand in this for this Cisco offering is that there is a line in the sand. There are 2 different Wi-Fi offerings from Cisco. Now, that being said, if you were to deploy a Catalyst AP or historically an AeroNet AP onto a Meraki network, you would run into some issues because you still need to have the wireless LAN controller for those. I'll just call them traditional APs from that standpoint, or traditional Cisco infrastructure APs.
Right.
That being said, the interesting part about the wireless LAN controllers, and that comes into this update with 802.11 or with 802.11.ax or Wi-Fi 6, is that the controllers needed to be updated to handle the updates to the data streams, the updates to the interface for those access points. And so there's a new kind of world coming out there for these what we call the 9800 wireless LAN controllers. And we actually have a learning lab for that, and I'll get to our learning labs in a minute for our developers out there. But that wireless LAN controller now supports a functionally specific version of iOS XE. So it is running something very similar to what the switches are running, And what that allows us to do is tie into the device level management of that wireless LAN controller. Now I can get into a whole rat hole about going managing devices directly or managing them through other controller type products. But the wireless LAN controller is a necessary item to have for that classic Cisco unified wireless networking. So that's the realm that we're living in. Now, from a developer standpoint, there's a general assumption that these things are deployed already. Now, a network engineer might go through the process of learning how to either through Cisco controllers like DNA Center or the Meraki Dashboard, which is really in and of itself is a large controller that's cloud deployed. They could go through and provision their networks, update the management, update the configuration of those devices, all of that fun stuff that we can do on the device locally. We're starting to see interfaces into those. And Meraki in and of itself, because it's a cloud managed service, fully, there's a whole set of what we call REST APIs that allow developers or network engineers to build out scripts or applications that take all of this. I'm actually move off of this network and move into one that has a little more stuff in it. So we're looking at right now an organization that I maintain as part of my lab, but it kind of shows how quickly things can blow up. And I actually saw a customer yesterday that had 1,000 different networks. So on the left-hand side here, I only have 6 as my personal management. But I saw a customer with 1,000 different networks that they had to manage all of the devices for those individual networks, and they broke everything out by their stores, basically. And so we can start to think about being able to be in an organization or a person that manages that number of networks, that many devices. These things can blow up and get really, really complicated.
Sorry to interrupt, mate. So the dashboard that we're looking at here, the Meraki dashboard,
yes.
That is really, I guess, just a front end making API calls to a back end, right? And so what I guess what we're saying here is that you've got the ability to make calls directly into that back end from your own scripts and making those REST API calls yourself. So I know Derek's favourite tool at the moment is Postman, and so you could literally write Postman stuff to make calls directly into that dashboard through the APIs. Is that what we're talking about?
That is exactly what we're talking about. And so the thing that I tend to cover when I look at the dashboard is they have to cover everything, right? They have to cover all of the potential security options in SD-WAN options. So everything that's in here, everything that's in switches, everything that's in wireless, all of those things, Meraki has to make available on their dashboard, which is all fine and good, except that's not always the way that an organization manages their IT, right? So it can be a little bit overwhelming. It can be a lot of tedious clicking and moving to the next screen, blah, 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 blah.
Especially when you've got 1,000 sites, right?
Exactly.
Yeah.
And so, and then you multiply those 1,000 sites by, I think these sites only had maybe 4 devices at them, but now we're talking about 4,000 devices that you're trying to manage.
Right.
Well, we can start to automate these things by interacting with them in the dashboard API, and we can build out either, at the baseline, just scripts. It can be Postman calls, or it can be full-fledged web applications that do things the way that you do them, rather than the way that Meraki has defined them. I mean, yes, you are tied to the way that Meraki has hierarchically set up their organization's networks and devices, but if you have a policy within your organization that you turn off all of your switch ports except for the ones that actually have, this is a pretty common one, but except for the ones that actually have cables plugged into them, you can do that across all of your switches with the API calls and loop through everything and not have to worry about that. And so what I'm showing right here is the documentation for that dashboard API that allows us to tie into this stuff. And in that, we see the ability to manage things like SSIDs And so if we have 1,000 networks and we have 1,000 SSIDs that we want to deploy, and they all need to have this similar configuration, they're using either a pre-shared key or they're deploying something called a captive portal that pops up on your screen when you log in. I can configure all of these things across all of the 1,000 networks that I have to deal with through API calls, and I don't have to go into each individual network and set those wireless settings up for my guest network that I'm having my customers use when they come into my store, site, or restaurant, or whatever it is.
It's important to note that this information comes with the product. So most of the products that we have, you're gonna not have to start learning the terminology and the steps on your own. The products actually walk you through, for example, this dashboard API, it walks you through trying to do what you intended to take to the developer. So that accurate, Matt, or?
That is accurate.